Welcome. Let's solve Leetcode 515. Find largest value in each tree. Okay, so the directions seem pretty simple. Let's make this bigger. Given the root of a binary tree, return an array of the largest value in each row of the tree, 0 indexed. So here's a tree and the biggest value for each. They call them row, but I think it'd be a little bit more accurate to call it level. But in any case, so 1, 3, and 9 are the results. And here, one thing to be aware of is that they could pass in 0 nodes. So that's something to be aware of before we start coding this. Okay, cool. I think that's enough to get started. I have been considering adding C++ to my submissions or videos, but I'm still thinking about it. In any case, I think that's good enough to get started. I don't think well, sure, we could leave this window open. Okay, so let's begin. So I'm going to use breadth first search, and we're going to go level by level. And so let's just go over it. I think it'll be okay. Let me change some of the settings really quickly. Let's change this to 2, and maybe that makes it a little bigger. Actually, let's just do 15. Okay, so I hope that's better to see. Okay, so let's use breadth first search. So typically for breadth first search, we use a double-ended queue to traverse traverse the structure we're interested in. So let me just call this queue equals double-ended queue, and we'll put the root in there. But remember, as I mentioned earlier, I almost forgot myself, the root may be nothing. So let's just check right now. If not root, return an empty, we can just do this, or result equals that, return that. At the end of our problem, we'll return result as well. Okay, we've gotten that out of the way. Now, we have a little bit of an issue. So suppose we're at this row here, 5, 3, 9, and how do we keep track? What's an efficient way of keeping track of, all right, let me see, how can we efficiently find the maximum for each row? Remember, that's what they want us to do, the largest value in each row. So what I recommend here is that we use a heap for each row or level, and then we just pop off the first value. So one thing to keep in mind though is that in Python, the heap is naturally a min heap, a minimum heap. So in order to get around that, and convert to a maximum heap, we will store the negative value. We will store negative value. And then when we pop it off, we'll just convert it back to its positive value. Okay, so let's continue. So let's traverse the tree. So while q, and sorry, well, sure. So we want to go for what? We don't really care about the index, in range length of q. So right now q just has one element, the root, and so we'll pop that off the heap. Sorry, the queue. So not pop it off, but this is a double-ended queue, so we'll remove the element to the left first. So we'll say node equals q dot pop left. Then we'll say, okay, now we'll add this to our heap. So we'll say, okay, heap push h negative node dot val. So remember, to get access to the value, we just use this here, dot val, and then remember we need to make our heap. So let's do that. So heap. We can do that here too. Maybe make this a little bit smaller. Okay, great. So what do we do next? So we need to prepare for the next level. So let's do that now. So we check if node.left, and let's add, if there's a left node, then we need to add it to the queue. So we say queue.append node.left. Then we do the same thing for the right. Okay, great. Okay, very good. So suppose we're here, 5, 3, 9s. Just imagine that we're on this row or level. In our heap, we would have 3 values, and we want the first value. So we say, okay, we can just say h of 0. Because remember, the way heaps work is that the very first index stores either the minimum or the maximum, depending what type of heap we're working with. We don't need to say heap pop. We don't need to do that. Then we say, okay, result dot append. Now remember, we made this maximum heap, so we're storing the maximum value, sorry, the negative values here. So that means we need to convert it back to a positive. Okay? Very good. Now, so what we've done here is we've stored this maximum value in our result. Is it result or result? Result. But we still have the heap. But remember, we want to, in essence, we want to clear each level. We want a brand new heap for every level. So let's do that here. We'll clear it. We'll just say, so natively, on its own, h is just a list. So I can just call h.clear, and that'll just empty the heap or that list h, so we can reuse it again. And now when we start the new row or the new level, it'll be restarted. It'll be empty, so then we can use it. Okay, I think that's good enough. Let's check it locally. Okay, looks good. Let's submit it. Okay, looks lovely. Cool. All right, very good. So if you found this video in any way helpful or beneficial, please consider liking or subscribing. Other than that, have a wonderful day. Take care of yourself.